Okay, hopefully helping out with some more exam questions answered. For revision, for mocks coming up, and for the final exam. Okay, volumes of revolution. The finite region bounded by the curve y is equal to some function of x, the line x is equal to 1/8, the x-axis, and the line x equals 8 is rotated through theta radians, not 2 pi, theta radians about the x-axis to form a solid of revolution. Given that the volume of the solid formed is 461 over 2 units cubed, use algebraic integration to find the angle theta through which the region is rotated for 8 marks. Okay, let's get started and let's do the math. So, the volume of revolution is between our points x equals 1/8 and x equal 8. So, we're going to find the integral of y squared dx around the x-axis between the points given, between x equals 1/8 and x equals 8. And we're going to find it to theta radians. Yeah. Okay. Now, the important thing to note is we have to divide our rotation. If it's theta, the rotation, we have to divide it by 2 because it's always half of the rotation. So we've got theta over 2 multiplied, whoops, that doesn't look like a 2. Yeah, there we go. The integral, and with limits 8, these are our boundaries, 8 and 1/8. Yep. And of course we're integrating y squared dx. And let's try to write properly. Y squared dx. So y squared dx, and yeah, now we can use our equation, which is given as y is equal to 2x to the third, 2x to the third, plus x to the minus 2/3. Now we're going to take out x to the third. If we take out x to the third, we're going to end up with 2 plus x to the minus 1. 2 plus x to the minus 1. And let's scroll down, and we now make y squared because that's what we want to integrate. So y squared will give us x to the 2/3, 2 plus x to the minus 1 all squared. And that will give us y squared is equal to x to the 2/3, yep, x to the 2/3, and now we've got to square all of that, so that's going to give us 4 plus 4x to the minus 1 plus x to the minus 2, plus x to the minus 2. And yeah, if we expand that, just expand all of that, we got y squared will be equal to 4x to the 2/3, 4x to the 2/3, it doesn't look like a 2, yeah, it's all in real time, 4x to the 2/3 plus 4x to the minus a third, 4x to the minus a third, plus x to the minus 4/3, plus x to the minus 4/3. And now we're going to put that all in because it says, yeah, given that the volume of the solid is formed given that the volume of the solid formed is 461 over 2. So we're going to use that. We're going to use 461 over 2 is equal to theta over 2 radians, and it's the integral of 8 and 1 over 8. These are bounds. And I'm so conscious of time, I have done this, of course, so I'm going to just summarize. 4x to the 2/3 plus 4 to x to the minus a third, 4x to the minus a third plus x to the minus 4 over 3. I can now go straight to 461 is equal to theta, because our 2's are eliminated, and of course we got our boundary conditions. 2/3 will add 1, 3 over 3, so that's going to be 5 over 3, and 3 over 5 times 4, that's going to give us 12 over 5, and x to the 5 over 3. And the similar rules applies there. That will give us 6x to the 2/3 plus 6x to the 2/3 and minus 3x to the minus a third. And we put our limits of 8 and 1 over 8. Now, you can go to your calculator at this point and substitute in 8 and 1 over 8 for x, and you're going to end up with 461 is equal to theta, and 103.7 I got, and of course that gives me theta equal to 461 over 103.7. 461 over 103.7 is equal to theta, and I got theta is equal to 4.45 radians. And that's it for, oh, that's nice, 7 minutes. That's it for, I'm not sure, is it 8 marks? 8 marks. Okay.